about a project that I did at the University of Florida this last year, and about a design program called the IPPD program that I participated in. First, I will go through by explaining what the IPPD program is at UF, and then explain what a dynamic cell culture system is, which relates to my project, and then I will go on to describe my actual project and its functionality. The IPPD program at UF is a program specifically designed for engineering students, where it places multidisciplinary teams of different engineering students in different groups. So the process of applying to IPPD is to go online and fill out an application, state your qualifications, and then if you are selected into the program, you go through a match process to pick a project. More information on this can be found at the IPPD website. I have cited here for you. My team was called Shock to the Heart. Our project was specifically geared towards designing a dynamic cell culture system to mimic cardiac tissue behavior. My team member was comprised of 4 biomedical engineers and 1 electrical engineer, and then myself, the chemical engineer, to each come up with specific roles and schedule different meetings to meet during the week. We met for exactly 1 year to form this project. First, I will describe what is a dynamic cell culture system. A dynamic cell culture system, as opposed to a static system, seen here, just lying flat, is where you would have your cells placed in a bioreactor. You would use this in studying cells during reactions, as opposed to just tissue engineering or growth, where you would just have a flat plate growing your tissues, no movement at all. My project was specifically research-based, where we would have a dynamic cell culture system where we would plate heart cells, as you can see our heart here beating. We would plate heart cells on a cell well plate, which would be moving and electrically stimulated at the same time to imitate the heart, because in the heart you have an electrical impulse and then a mechanical contraction, and that's how your heart beats. This could be used in a dynamic cell culture system, could be used in pharmacy to watch how drug interactions happen in vivo, which in vivo means in the body, in vitro is outside of the body, so that's where you would use a static cell culture system. More information on static versus dynamic cell culture systems and research and industry can be found at the UKSA's website. That is where I got this information. Our project again was to incorporate this mechanical stretching device, which was designed by Dr. Chelsea Simmons at the University of Florida, to a cell well plate of cardiac cells, which we would apply an electrical impulse to imitate cardiac behavior. And then at the same time, we would use this device by Chelsea Simmons to mechanically stretch our cells. In order to further develop this process, we had to have some cell viability testing, which cell viability means, did the cells live or did they die? So we created a lid system to go on top of our cell well plate, as you'd seen previous slides before, and we had electrical wires conducting through each of the well plates. These 2 electrical wires were actually stimulating the cells. This electrical wire was not stimulating the cells, and the last one was just a control to see if maybe our lid killed the cells or not. So the achievements of our project, it did end up working. We incorporated the lid with our electrodes into our mechanical stretching device, and we were able to shock our heart cells and able to stretch them at the same time. The silver wire did not kill our cells. We formed a uniform electric field, which means there was a constant electricity across all the cells instead of just one spot, and our product was roughly inexpensive. Our lid only cost about $150. The drawbacks to this can be that we did not fully get the stretching and electrical systems together, because that required some advanced programming that we just could not do because we were still undergraduates. And we use smooth muscle cells as opposed to cardiac cells, but in future research this will be used for cardiac cells. And this is my works cited page. I just wanted to conclude with saying that this project will be further advanced next year, and I'm excited to hear about the future of our cell culture system. Thank you.